Good afternoon. I'm Salka with Panoramic Power. We are an Israeli startup doing work in the area of commercial building energy efficiency. So energy is a hot topic today. Whether one is concerned with climate change or cost containment or any one of a number of other factors, people and organizations around the world are looking to reduce the energy that they use. So against the adage of you cannot manage what you cannot measure, and 120 years after Thomas Edison started the world's first electric company, what do we really know about how power is used? Well, we know a lot about how power is generated, and we know a lot about how power is transmitted, but what about the usage of that power? That's something which 120 years later, we still know virtually nothing about how power is used. It's really a last mile kind of problem because for the most part, where we measure power ends at the meter outside of the building. And with that meter, we get one bill. It tells us how much energy we've used for a month and how much money we have to pay. So on that bill, we know virtually nothing about how or when or where that power was used. So what's the answer? There's a lot of talk about smart meters. Smart meters will answer the question of when and how much, but doesn't really tell us anything about how the energy was used. So should we measure each and every endpoint? I'm not sure that we want to solve a problem of too little data with too much data, not to mention the immense cost and complexity of doing that. So we really have here a kind of Goldilocks dilemma. How much is just right? So suppose we could measure electricity at the circuit level. Circuit level is kind of interesting because of the metadata that we can associate with that individual circuit. An individual circuit has a load type. It's plug loads, it's lights, it's HVAC. It has a physical endpoint in a building where that power is consumed. And because we know where it ends, we know what people or what organization within that building are using that power. Of course, if we're measuring on a constant 24/7 basis, we know a lot more about when the power are used. And we can use this data to detect and respond to anomalies when they occur. And of course, the measurement itself represents the how much. We call this asset-level real-time monitoring. With it, of course, comes a big data story. In the US, there's about one circuit per 100 square feet. In commercial buildings, so we're talking roughly 6 times the number of worldwide cell phones if we were to measure everything. So as the electricity is flowing through those circuits, it's generating a magnetic induction field. And if we think about it, that field is not simply a byproduct of the electrons flowing through the wire. It really represents data about power. So what would happen if we could use that magnetic field to power the sensors that are actually doing the measurement of that field itself? And that is what we've done. So we've developed a small, wireless, low-cost, self-powered sensor that simply snaps around an existing wire in a commercial electrical panel. So the physical installation is very simple. It's literally snapping a plastic case around the wire. It's non-invasive. There's no need to shut off the power or it doesn't have any effect on operations to install it. So you simply snap that sensor around the wire and then catalog the metadata that's associated with that particular sensor. The sensor uses an RFID-like protocol to communicate from within the electrical panel to a box outside, and then the data are uploaded to a hosted database. And there, we can perform analytics, we can render visualizations, and run data mining algorithms. So let's take a look at a real-world example. This is a large supermarket. They're measuring condensers in their chillers. And you see here there's a normal peaks and valley. And all of a sudden, everything drops because there's a power outage. And now notice what happens when the power comes back on. This one condenser, the blue one, spikes up and it runs nonstop at 100%. So without the ability to detect that anomaly, you'd be looking at a waste of about $5,000 a year, not to mention the cost of replacing that equipment prematurely. So from these data, we gain insight about operations, organizations, and the locations in which they operate. And that enables action on the part of individuals, organizations, and even across institutions. So from this, we end up with the world's first database of granular energy data, which can be used not only to increase energy efficiency and drive cost savings, but further, taken by other stakeholders, can be used to improve building standards and reliability of different equipment. All of this simply by transforming that byproduct of energy flowing through the wire into the missing ingredient of energy management. Thank you.